Okay, this is a solution to problem number 33 on page 512, and this is not the ideal format in which I like to post video lessons, but this is what I have to go with today. So in this problem, there was a Yankee salaries for the year 2001 were $1.6 million, and for the year 2009, the salaries were $5.2 million. And something that's not stated in this problem, but you just assume because of the section that you're in, is that we're assuming a linear relationship between the year and the salary. So you're asked for two things here, and you have to do both things. One of the things is to find an equation relating the salary to the year with y in terms of x. Now, something that's not explicitly stated that we make a decision on, and you could make a choice about this, and the choice that you make does not affect the outcome of the final solution, which is what is the salary projected to be in the year 2017. So the choice that we have to make is that we are going to we're going to do an equation, and this is the way I like to indicate. We're going to do an equation y in terms of x. So x is going to be my input and y is going to be my output. And so the choice that we're making is what is y going to be and what is x going to be. Typically, you are going to let y depend upon the year. So you're typically going to say, what year is it? And that's going to determine what my salary is going to be, as opposed to thinking about it as what's the salary, and that's going to determine what year it is. And both, like I say, both would work, but typically what we're going to do is we're going to say that y, in this case, is going to represent the salaries, and that is going to depend upon the year x. Another thing that we do in this problem that is just a convention that we use is we will typically not use 2001 to represent the year. We're typically going to say that 1 is going to represent 2001, and 9 is going to represent 2009. So in order to let everybody know that we're doing that, so that it's not just assumed, we're going to say x is the year, and I'll say x equals 0 is the year 2000, and just state that right at the beginning. Now, the next thing to recognize here, whenever we are entering a situation where you're asked for a linear equation and you have some data, or whenever you are really entering any situation that you have a relationship between two things that vary, that you know is a linear relationship, or you're going to treat as a linear relationship, you can automatically go back to think about what's the first sort of experience that we had with lines. And that was that we were given 2 points, and we were asked to find an equation of the line through those 2 points. So in this case, our 2 points, and the 2 points are 2 numeric values, right? Or 2 sets of numeric values. So the 2 values that we have here are 2001, which we're going to call 1, as I said, and $1.6 million. This is another choice that we will typically make in this case. We're going to talk in millions of dollars. So I might even say that here, that y is the salary in millions. So that way, when I write 1.6 here, that means $1.6 million. And you can understand why that would be preferable to actually writing out $1,600,000. That's just taking up more space. So we're going to write the 1.6 to represent $1.6 million. My input is the year, and that is 1 in this case. And then My input here is 9, representing the year 2009, and my output is 5.2. Now from there, one thing that I just want you to stop and consider, could you figure out in even a non-math class sort of way, what would we project the salary to be in 2017 if this is the case in 2001 and 2009, and if we're assuming a linear relationship? Could you figure out what the salary would be in 2017? Yes, I think you could. Now, in this case, we're going to really math class things or mathematize things and then do it in a math class way. So we're going to find an equation, and then we're going to use that equation to find the salary in 2017. So really, we don't even have to think about the context at this point. Now that I've got these 2 points, now I just revert back to what I know about linear equations. So slope, what's the first thing that I would find is? I would find that slope is equal to the change in y. So we'll do 5.2 minus 1.6 over the change in x. And that gives us 3.6 over 8, which we could simplify that to, I believe, 0.45. Or we could write that as a decimal, as 0.45. Once we have the slope, now there are 2 ways to go here. Really the easiest way to go is if you use this equation. Y minus y1, some point that I know is on the line, is equal to the slope times x minus x1, the x value that goes with that y value for the point that I know that lies on the line. Now you could go in the other direction, another direction, and you could use y equals mx plus b. But if you do this, if you do y equals mx plus b, then you're going to have to solve for b, which that's going to take another step. So I would say use this equation, and hopefully you remember that equation. If you don't remember that equation perfectly all of the time, then you should probably use this equation and solve for b. And I may address that depending on the time here, but I do like to keep these under 10 minutes. So I'm going to go y minus, I can choose either one of these. So let's say I go 1.6, I'll take that y value, is equal to m, which is the slope, which we found here, that's 0.45, times x minus x1. It has to be the x value that goes with this y value, right? So I could not mistakenly take 9 and have this come out correctly. So I need the 1 here. And there, that's an equation of y in terms of x. Now you may like to solve that for y and say y is equal to whatever that equals, and that would be appropriate, and that might be more appropriate to do that. But it's not absolutely necessary, especially based upon how the instructions for the problem were worded. So let's go ahead and continue here. I'm not going to solve for y. I'm just going to find out what the salary is in 2017. So I'm going to say I'm looking for the salary, which is y, which we stated up here, and I'm going to say what is the salary when x is equal to 17. And that's it. Then I just need to solve for y. So solving for y, in this case, that's the single variable that is left. I just put an arrow over here and say y is equal to 8.8. And of course, I know that because I'm doing my salaries in millions, of course I know that 8.8 means 8.8 million. And I should answer the question as such somewhere. I should say 8.8 million in 2017. And then there's that part of the solution, and here's this part of the solution. I've taken both parts, an equation for oops, I boxed the wrong one. Let's do this one up here. So that's the equation for y in terms of x. If we just jump to this, actually, which some people in the assignment might do, that you haven't actually addressed the question of writing y in terms of x, which later on we're going to talk about writing y as a function of x. So this is a very important element, not to determining the 8.8 million, but it is important for the way that we want to be engaging with mathematics over the next few months, which is in a function format. So there's the equation, and there's the solution to the question about 2017. And that's my time limit. Again, you can do it like this, but you would need to solve for b by using one of the known points, and of course we know m already, and you would need to show your work for that. And then when you get that equation, then you would substitute again 17 for x and come out with the 8.8.